So welcome students. Let us look at the topic of trigonometry. And the focus of this video is to understand what trigonometry is. So as the name suggests, trigonometry is made up of two subwords, which is trigono and metro. So these two are Greek words. So the first word is trigonos and the second word is metros. So trigon, tri means three, gon means angles. So you would have already heard the words polygon and pentagon, hexagon, so on. So gon means angles, and you have three angles, that is a three-sided figure is called a triangle or a trigon. And metros means measurement. So trigonometry basically deals with measurement of triangles. So you might be wondering what measurement of triangle is. So if you take a triangle, let us call it ABC. So what are the things that you need to measure? What are the things that can be measured in this triangle? So there are three sides of this triangle. So let us call the side opposite to A as small a, the side opposite to B is small b, the side opposite to C is small c. So let us say that there are three sides of a triangle ABC, and you can also see that there are three angles of a triangle: angle A, angle B, angle C. So these are the very basic properties of a triangle. So if you want to understand what the triangle is, if you know all this, you understand what this triangle is. So these are the things that you need to measure. So there are six basic parameters that you need to measure: the sides, the three sides A, B, C, and the three angles capital A, capital B, capital C. So but the question is, are these six parameters independent of each other? Are these six parameters of triangle independent of each other? The answer is no. So if you want to understand about a triangle, it looks like you need to know all the six. But in reality, you don't need all the six parameters. If you know certain parameters, you can find the remaining parameters. As you have understood in your chapter of constructions. So in your lower classes, you have the chapter of constructions. So just try to remember what you have done in that chapter. So if you want to draw a triangle, how many informations are given to you? So as you can vaguely remember, you can so for construction of a triangle, you need three measurements, right? So for a triangle, you need three measurements. That is, if you are given three measurements of a triangle, the triangle gets fixed and all the other parameters get fixed. So if you are given three sides of a triangle, you can actually construct the triangle. And once you construct the triangle, I don't need to give you the three angles. Three angles can be measured by you from these sides. So out of these six parameters, not all parameters are independent. So only three parameters are independent. That means out of these six, if I give you any three parameters, so I can get the other parameters. But all the three parameters have to be independent. So I need three parameters which are independent of each other. That is, if I give you three numbers, I should not be able to get one number from the other two numbers. Something like, if I give you angles A, B, C, these are not three independent parameters. Because angle A and B, if you know, you can automatically calculate C. So that's not a new information because we know that the sum of angles of a triangle is 180 degrees. So what you need to understand is, if you want to measure the properties of a triangle, you don't need all the six parameters. You need some of them. And this chapter deals with what you need to know to find the other parameters, and you'll also get how to find the other parameters if some parameters are given. So trigonometry in general deals with a general triangle, a scalene triangle, right? But that's not where we start. So trigonometry doesn't start with scalene triangle. it ends with scalene triangle. That's a complete form of trigonometry. But in the starting, observing scalene triangle looks somewhat difficult. So initially we start with a simple triangle. So obviously, as you know, what is the most simple triangle? The most simple triangle will be the equilateral triangle, right? The most simple triangle will be an equilateral triangle. But equilateral triangle is not challenging, because if you know this side, you know everything about the triangle. If you know one side, you know everything about the triangle. You don't need to know anything else, right? So if you know the side is 6, you know all the parameters, because all the angles are 60 degrees and the remaining sides are also 6 centimeters. So we need not so difficult problem, not so easy problem. We need something in the middle to study and understand how a triangle works. So what has been selected is, as the basic tool for studying trigonometry, is a right angle triangle. So a right angle triangle is a triangle which is not very difficult, but also not very easy. So this is a good starting point for trigonometry. So this is where we start. So what's the beauty of a right angle triangle? So right angle triangle is beautiful in 2 ways. The first way is Pythagoras theorem. So there is a very simple way in which you can relate the 3 sides of a right angle triangle. So this is not possible for a scalene triangle. So in scalene triangle also you can relate it once you derive everything, but it's not very easy as you have a right angle triangle. In right angle triangle, you can always write hypotenuse square is equal to sum of squares of the other 2 sides. This is a special property which is valid only for right angle triangles. So the second beauty of right angle triangles is with regard to similar triangles. So usually if 2 triangles have to be similar, then at least 2 of their angles have to be equal. So in a right angle triangles, one angle has already been equal. If you take 2 triangles, one of the angle has already been 90 degrees. So if one of the other angle is equal in both the triangles, then these 2 triangles become similar. So if this theta is equal to this theta, then triangle ABC is similar to triangle DEF. Not congruent, is similar to triangle DEF. So the similarity of 2 triangles depends only on one angle. So what happens if these 2 triangles are similar? So if these 2 triangles are similar, ratios of corresponding sides, ratios of any 2 corresponding sides is equal. So ratio of any 2 corresponding sides are equal. That means if I take this as AC by AB should be same as DF by D. Not just in these 2 triangles. If you consider another triangle, another right angle triangle with the same angle theta, in this triangle also this side by this side is same. So if you take any right angle triangle with angle theta, the opposite side by adjacent side of this triangle is same as opposite side by adjacent side of this triangle is same as opposite side by adjacent side of this triangle, so on. So in all these triangles, the ratio of any 2 sides depends only on the angle. As long as the angle is equal, the ratio of sides does not change. So that means in the second property we say that the ratio of sides of a right triangle depends only on theta. Depends only on theta. That is, if theta is same, the ratios are same. If theta is different, the ratios are different. So we define 6 trigonometric ratios with respect to this property. 6 trigonometric ratios are defined using this as the property. So you have already learned the 6 trigonometric ratios. Those are nothing but sine theta, cos theta, tan theta, secant theta, cosecant theta, and cot theta. Obviously, if you have three sides, if you have, let us say that if you have three sides A, B, C, how many ratios can be defined? There are 6 ratios that can be defined. These are the only 6 ratios that can be defined, and all of them are defined. So let us see what these ratios are. So if you take a right angle triangle where one of the angle is theta, for this triangle 6 trigonometric ratios are defined. Those are nothing but sine theta, sine of this angle, cos of this angle, cos theta, tan theta, cosecant theta, secant theta, and cot theta. And these are shortcuts. Sine is a shortcut for SINE, and cos is a shortcut for cosine. We have sine, cosine. Tan is the short form for tangent. So tangent of theta, cotangent of theta. Secant of theta, cosecant of theta. Sine, cosine, tangent, cotangent, secant, cosecant. So let us see what each of these ratios are. Sine theta is defined as the opposite side by hypotenuse. Opposite side by hypotenuse. So as you can see, if you take any right angle triangle, one of the angle is 90. So if you take another angle as theta, with respect to this angle, hypotenuse is always fixed for this triangle. There are two right angle sides. With respect to this theta, one side which is adjacent to theta is called adjacent side. The side opposite to theta is called opposite side. Opposite side, adjacent side. Sometimes opposite side is also called perpendicular. Adjacent side is also called base. There are two different notations. I am going to use the first notation. Opposite side, adjacent side, and hypotenuse. Okay. So sine theta is defined as opposite side by hypotenuse. Cos theta is defined as adjacent side by hypotenuse. In some textbooks it is written as perpendicular by hypotenuse, P by H, both are same. Cos theta is B by H, both are same. And tan theta is defined as opposite side by adjacent side, O by A. Opposite side by adjacent side. Next, cosecant theta is the reciprocal of sine theta. Sine theta is O by H, opposite side by hypotenuse. Cosecant theta is hypotenuse by opposite side. And secant is the reciprocal of cos theta. So hypotenuse by adjacent side. Cot theta is the reciprocal of tan theta. O by A, opposite by adjacent is tan. Adjacent by opposite is cot theta. So these are 6 trigonometric ratios which you need to remember. So what is the shortcut for remembering? So you can remember these trigonometric ratios using the acronym SOCA2. SOCA2. That is, sine starts with opposite side. Sine is opposite side by hypotenuse. Cos starts with adjacent side. So adjacent side by hypotenuse is cos. Tan starts with opposite side. That is opposite side by adjacent side. You can remember this much, that in sine and cos you get hypotenuse also. And tan is the ratio of two right angle sides. The confusion comes whether we start with A or you start with O. So you can very easily remember the formulas for sine, cos and tan using the acronym SOCA2. It is, if you are from Hindi background, you can see this as sow, means you sow the seeds. You can think of it as you sow the seeds, and kato. So once the seeds become plants, you cut them. So kato in Hindi means cut. So you sow and you cut. So kato. So SO, sine is starting with opposite side by hypotenuse. Cos starts with adjacent side and ends with hypotenuse. Tan starts with opposite side and goes to adjacent side. So sine is opposite by hypotenuse. Cos is adjacent by hypotenuse. Tan is opposite by adjacent. And you can remember cosecant, secant and cot as the reciprocals of these trigonometric ratios. So as the saying goes, the utility of a tool depends on the skill of the hands that use it. So this trigonometry is a tool, and legendary people have used this tool to get some really astonishing results. For example, Eratosthenes of Greece has calculated the radius of Earth using the principles of trigonometry. Similarly, Aryabhatta of India calculated the ratio of distance between Earth to Sun to Earth to Moon using the concepts of trigonometry. And people have calculated the distance between faraway stars using the concept of triangulation. And the width of the rivers, navigation charts for voyages, for example, maps of the world map or the maps like that, and this trigonometry is also used in surveying. And the uses of trigonometry goes on and on. And recently the GPS system which we use uses the concepts of trigonometry. The navigation systems for all the machines that we use depend on basic trigonometry. So the uses of trigonometry are endless. But trigonometry starts with very basic principles which you need to understand thoroughly. So come, let's have fun learning trigonometry. Thank you.